Now, these problems we've got here require us to do a little bit of extra work before we actually get down to a situation where we can find our angles. So the first one here, we've got sine of theta all squared is equal to 1. Well, we've got to consider the idea that if we want to get theta by itself, we need to take the square root because we want sine theta. If you take the square root of 1 though, you get plus or minus 1 because plus 1 all squared gives us 1 and minus 1 all squared gives us 1. So we come to the situation where sine theta could equal 1 or it could equal minus 1. So we have two situations there. Well, we know where sine theta is equal to 1 is 90 degrees and sine theta is equal to minus 1 at 270. Should have said first that theta is between 0 and 360 again because sine theta is equal to minus 1 at minus 90 as well, and all the revolutions at 360 for each of those ones. But again, we've only got the two solutions because we're only in one revolution between 0 and 360 degrees. So we should keep that in mind. What's our domain for theta? So this one has a bit more manipulation. So we want, again, to get down to tan of theta by itself, but we need to divide by 3 and then take the square root, which we can start to see that we get two solutions for tan of theta. We get plus or minus 1 on root 3 because square root of both those, we have to take the positive and negative square roots. So for tan of theta is equal to 1 on root 3. So we're going to consider two different equations. We've got two equations here. Tan theta is equal to 1 on root 3 and tan theta is equal to minus 1 on root 3. So let's consider this one like we did in the first video. So what's our related angle? 1 on root 3 gives us 30 degrees. So when we take inverse tan of it, and tan's positive in the first and third quadrant. So our related angle's 30 there. In the third quadrant, we're going to add 30 to 180, gives us 210. So there's two of our solutions. Because tan of tan of theta is equal to positive 1 on root 3 gives those two solutions. Now, if tan of theta is equal to minus 1 on root 3, so our related angle then would still be 30 degrees. So ignoring the negative, we're still going to get the 30, it's exactly the same there. But we know this time tan's negative in the second and fourth quadrant, which gives us the related angle from 180 and from 360 gives us those two solutions. So really, for this equation, it has four solutions: 330 degrees, 210, 150, and 330 degrees. All will satisfy that. Again, you could throw that into your calculator. 3 times tan of 30 degrees, which is all squared. So tan of 30, square it, times it by 3 will give you 1. So if you change that angle for 210, 150, or 330, that will always give you 1 when you put that in. And the reason being is that tan of 150 is equal to minus 1 on root 3, and when you square that gives you positive 1/3, and 3 times positive 1/3 would give you 1. So that's the idea and why it would always be, it should always work. But 4 solutions, and that's okay. That's okay in this situation. Again, one with the squared. So again, we might be anticipating 4 solutions, even though in question 1 we only had 2, but that was because it was equal to, the related angles are 90 degrees. But this time, so we divide by 4, take the square root, we get the positive and negative of root 3 on 2. Now you're seeing that we're getting our exact values coming up, so it's not working out too badly for us in that case because we've seen lots of these already. So we get our related angle when sine is equal to root 3 on 2 gives us 60. So the related angle for both of these is the same. But we've got sine where it's positive in the first and second, so we get our related angle, and 180 minus the related angle gives us 120. And in the third quadrant here, and the fourth quadrant, we get sine being negative. So we're going to have the other two solutions in those two quadrants. So we add 60 to 180 to give us 240 and subtract 60 from 360 to give us 300. So there's our 4 solutions for that. Again, go back and check. Like any equation we do, we can go back and check it, so we should do that. This time we've got 8 times cosine of cos cubed of theta minus 1. So again, we get down to the idea we can get cos by itself. Now notice here, we took the 1 across, gave us positive, divided by 8, and the cube root of that is only 1/2. So we're only going to get 2 solutions for this. We don't get positive or negative. That only happens when it's an even power. Odd power, it's only going to be the one solution. Because it was positive, we get a positive answer. If that was negative, we get a negative answer. Our related angle is going to be 60 degrees, and cosine's positive in the first and the fourth, so we're able to get those solutions. So just don't think, oh, because I see a power, I'm going to get a positive and negative answer. No, it doesn't work that way. So you've got to solve it through correctly and get whether the solutions, whether it works out as no solutions, 1 solution, 2 solutions, or 4 solutions for these types of questions. That would be okay. So there's some harder problems you're going to see. And again, it's really just manipulating them all back to getting an equation that we had like we had before, and being able to solve there, getting our related angle and where our trig ratio is positive and negative.